Hey guys, welcome back to my YouTube channel. Today I'm going to be talking about the quotient rule for finding the derivative. So with the quotient rule, we normally have a function that looks something like this. And then we have basically some sort of function divided by another one. So something over something. So typically when we use this rule, we have the form of this. So we are trying to find a derivative of f of x. And so if we have a form of this, and we're trying to find a derivative of f of x, all we need to do, right, there's a formula for that, and that's the quotient rule. So basically, we have to find a derivative of the numerator, so derivative of the numerator, and then we have to multiply that by the denominator, and then subtract the derivative of the denominator times the numerator, and this is all over the square of the denominator. So we're going to square the denominator like that. And this is basically the derivative of a function of this form. So to illustrate this with an example, say we have f of x is equal to 6 times x cubed minus 4 all over x squared plus x minus 5. So we want to find a derivative of f of x in this case. So we're trying to find f prime of x. So here we have this format, right? G of x over h of x. So our g of x is like this numerator right here. So our g of x is this. This is our g of x. And this here in the box, basically in the denominator, is our h of x. Okay, and this is a fraction line dividing both of them. So basically we will treat this as our g of x and treat this as our h of x, right? Like that. So we have to find a derivative of the top and bottom. And here is the g of x, so I'm going to find a derivative of g of x first to find g prime of x. So g prime of x, right? G prime of x is going to be equal to a derivative of this numerator. So the derivative of this numerator, we will basically look at it and we see this is, we can use the power rule for finding the derivative. So we take this 3 down like that. So it would be 6 times 3, right? 6 times 3. And then there's an x here. And then it's to the exponent of 3 as shown here. And we must subtract 1 from that using the power rule. And here this is a constant, so the derivative of a constant is going to be 0, so we don't have to write it. So it's going to be plus 0, but not necessary to write that. And then here just simplify it, so 18, 6 times 3 is 18, times x squared, like that. That's g prime of x. Now h prime of x, we look at the derivative of this denominator. So the derivative of this denominator, we can use the power rule again. So here we take this 2 down, and then here this is x, right? So x is the same as x to the exponent of 1. So we also take this 1 down like that. So it's going to basically, if we look at this, right, we take the 2 down, it's going to be 2x. And why is it 2x? Well, 2 minus 1, right, because this is to the exponent of 2, so we subtract 1. Okay, it's going to be 2x to the exponent of 1. Here we take this 1 down, and it's going to be 1 times x. Well, 1 times x is just x, so it's going to be x. And then the 1 here, right, minus 1. Okay, power rule, because we have to subtract 1 from the exponent. And then here it's a constant, negative 5 is a constant, so we find a derivative of that, it's just going to be plus 0. We're not going to write that, right? And then here we just simplify, so 2 times x to the exponent of 1, and this is plus x to the exponent of 0, which is just 1. So this is essentially 2x plus 1. So that is h prime of x. Now, since we found g prime of x and h prime of x, we can substitute that into our equation right here, along with g of x and h of x. So to find the derivative of f of x, f prime of x, we are going to substitute in g prime of x, which is 18x squared for here. So it's going to be 18x squared right here. And then h of x is equal to this denominator, right? This denominator is h of x. So I'm going to substitute the denominator, this here, x squared plus x minus 5. The denominator is equal to h of x as shown before here, right? So this is our original function. This is h of x. This is g of x. So I substitute in h of x, okay? And then now we have to substitute in h prime of x, which is right here. So I'm going to substitute that in. Well, we have to subtract as shown right here. So subtract h prime of x, which is 2x plus 1, and then times g of x. G of x is equal to this numerator right here, 6 times x cubed minus 4. So we sub in g of x as shown in right here. So I'm going to write it in. G of x is the numerator from the original function as shown here, because this function has this format. So g of x is at the top, right here, corresponding. Now, h of x is what is in the denominator right here, because this here corresponds to this, right? This was the function corresponding to this form. So the denominator is x squared plus x minus 5. So this is h of x. So I'm going to square the denominator. Just taking this and squaring it. And now we have found out f prime of x, and if you want to simplify it, what you have to do is we're going to use the distributive property. So we'll distribute this here and here. So 18x squared times x squared is 18x to the exponent of 4. And then 18x squared times x is going to be 18x cubed. And then 18x squared times negative 5 is going to be negative 90x squared. And then here, this is negative, right? And then I'm going to write everything, like all of this, in square brackets. So I'm going to basically take 2x and distribute this. 2x times 6x cubed is going to be 12x4. 2x times negative 4 is going to be negative 8x. 1 times 6x cubed is going to be 6x cubed. 1 times negative 4 is going to be negative 4. Then x squared plus x minus 5 squared. Okay, and now we can just simplify. So collecting like terms, 18x4 plus 18x3. Well, before we collect like terms, we can distribute these, right? Distribute this negative into each one. So negative 12x4 plus this negative 8x, negative positive, it's going to be negative 6x cubed, negative positive 4, all over x squared plus x minus 5 squared. And then here we can simplify this. So collecting like terms now, 18x to the exponent of 4 minus 12x to the exponent of 4, 18x cubed minus 6x cubed minus 90x plus 8x plus 4. This is all over x squared plus x minus 5 squared. And here you can add these like terms together. So 18 minus 12 is going to be 6x to the exponent of 4. 18x cubed minus 6x cubed is going to give positive 12x cubed. This is negative 90x squared, so negative 90x squared. And then here it's positive 8x and adding 4. x squared plus x minus 5 squared. Copying this. And there we have it. This is the derivative, right? F prime of x of f of x. So now say we have to find a derivative of this function, f of x. Okay, we have to apply the quotient rule here because we have a dividing line here. So this part is going to be our g of x, and this part is going to be our h of x. Okay, so this part is going to be our g of x, numerator is g of x, and then denominator is going to be our h of x. Okay, so think of it that way. F prime of x is equal to, well, the formula for quotient rule, we have g prime of x times h of x minus h prime of x times g of x all over h of x squared, like that. And so we have to basically find a derivative of the numerator and the denominator. So to find a derivative, g of x, right? So g prime of x is going to be a derivative. We basically take the derivative of this numerator. So the derivative of 2x minus e to the exponent of 2x, if you find that here, this is exponent of 1, so using power rule, take this 1 down, okay? It's going to be 2 times 1, so it's going to be 2, and if you subtract 1 from this exponent, it's going to be x to the exponent of 0. Okay, and then here, you can use the chain rule. We know a derivative of an exponential function is going to be simply, well, if you have like e to exponent of something, like let's say x, right? The derivative of that is going to be e to the exponent of x ln e, which is the same as e to the exponent of x, right? So say this is y, and you're trying to find y prime. That's the derivative. It's going to be e to the exponent of x. So it's going to be itself. So e to the exponent of 2x is going to be itself. But also we have to apply a chain rule, okay? So applying the chain rule, you will basically have to differentiate the 2x as well. So first you write out a derivative of the big part. So this is the bigger part, e to the exponent of 2x. Then the smaller part, you have to find a derivative of 2x. And we know a derivative of 2x as shown here, right? This is x to the exponent of 1. And then you would have to take that down, and then it's going to be just 2, right? So it's going to be 2 times x to the exponent of 0, which is just 2. Okay, this is just 2, by the way. Haven't simplified that yet because this will, x to the exponent of 0 is just going to be 1. So 2 times 1 is going to be 2. So here we found the derivative of this tiny part and the big parts. Okay, so here we have e to the exponent of 2x times 2. And if we rewrite that, it would be 2 minus 2 times e to the exponent of 2x. And that's g prime of x. Now to find the derivative of h of x, it's going to be the derivative of ln x, because this is our h of x. Derivative of ln x is 1 over x. Just like that. So we have found the derivative of g of x and h of x. And now we're just going to plug them in. So g prime of x, we have to plug in here. So it's going to be 2 minus 2 times e to the exponent of 2x. Plug that in here. H of x is ln x, so writing that in. Minus h prime of x, which is 1 over x. So I'm going to write that in for this h prime of x. And then g of x is equal to this numerator right here, so it's 2x minus e to the exponent of 2x. So copying this numerator into g of x right here. H prime of x is 1 over x, so copy that here. H of x is ln x shown here. G prime of x is this, right? So I copy that here. Good. Okay, now the denominator, we just square h of x, so here ln x is our h of x. So I'm gonna put that in brackets and square. Just like that. And then what I can do next is I can simplify this. So I'm going to distribute ln x to each term. So ln x times this and times this. So 2 times ln x, and then this whole thing times ln x. So negative 2 e to the exponent of 2x times ln x. Then here, it's negative 1 over x times 2x. So it's 2x over x, right? And then we did that, and now we do this. So it's going to be negative, and negative makes a positive, so positive e to the exponent of 2x over x, just like that. And then copying the denominator here, okay? And then this x and this x cancel, and then what we can do is we can simplify this a bit more. I'm just going to rewrite it. Minus 2 plus e to the exponent of 2x over x all over ln x squared. Now, I see this over x, right? I think it would look better if I multiply all the terms by x, so multiplying basically the top by x and the bottom by x, like kind of like a equivalent fraction, okay? So I'm multiplying the whole thing here by x, and I'm multiplying the whole thing here by x, okay? So just to make it look better, get rid of this denominator, right? So x times 2 ln x is going to be 2x ln x. X times negative 2 times e to the exponent of 2x times ln x is going to be negative 2 e to x. I'm going to put the x here, this x is right here, right? And then ln x minus 2, right? 2x, so 2x. And then here, the x times this, right? This is x to the exponent of negative 1 if we were to write it in the numerator. Well, this x and this x in the denominator are going to cancel. So it's just going to be positive e to the exponent of 2x. And this is all over x times ln x squared, just like that. Alright, so we have found the derivative of f of x. And that's it. So this is the end of my video. Thank you for watching. Feel free to give this video a big thumbs up if you found it helpful. Furthermore, I always love to know your thoughts on my videos, so feel free to leave a comment down below. And if you are new to my channel, feel free to hit that subscribe button. Anyways, I hope to see you next time for another math video. Bye!